In this video, you will learn how to set up a structural mechanics analysis using the SimScale platform. Let's first take a look at the geometry you meshed in the last video. It is a steel wall mount that supports the load of a heavy industrial machine. On the picture you can see how this part works. The vertical part is bolted with 4 screws on the wall. The weight of the machine is acting with a force of 20 tons on a round indentation on the surface, which is equivalent to a pressure of 15 megapascals. Running a structural simulation of this mount will allow us to determine the displacement and stress distribution within the part. Based on these results, we could later on optimize the design of the part regarding material use. Let's now switch back to the platform and set up our first simulation. For this, you need the mesh that we created in the last video. We will first select the project wall mount from the project list on the left side of your screen. Now switch to the Simulation Designer by clicking the corresponding button in the main ribbon bar at the top of your screen. Click on the Create New Simulation button to start the simulation setup. This will open a window where you can specify a name for your simulation. The default name is fine. After this, you can choose between several analysis types. Choose Solid Mechanics on the left and Static Analysis on the right. Now you will notice that several new items were added to the project tree on the left side. This tree will guide us through the next steps. Please note that some of the items on the tree are optional. Select the domain item in the project tree and choose your mesh. Ignore the geometries option. The 3D window on the right side of your screen will be updated. Now we can start with the actual setup of the simulation. We will define the material properties as well as the boundary conditions which show how the part is interacting with the environment. Clicking on the model section in the project tree allows you to define the model assumptions you want to use. Due to the fact that we assume very small deformations and that the weight of the mount itself is very small compared to the external force, you don't have to change these settings. Next, we have to set up the material properties. Click on the Materials item in the tree and click the Add Material button. This will open a new window in the middle row which has the material properties of steel by default, which we will use for this simulation. You now only have to assign this material to the solid by selecting it from the list below. SimScale also comes with a material library which contains models for the most common materials. To access this ready-to-use model, you have to click on the Import for Material Library button, which will open a window where you can choose the material you want to use. We will now define the boundary conditions, which describe the case you want to simulate. You should remember the sketch from the beginning. Click on the Boundary Condition item in the project tree. This will open a new menu in the middle column. Here you can create loads such as external forces and torques, and linear constraints such as fixation. We will start with the external force. Click on the Add Load Boundary Condition button. Then select pressure as the type and define a value of 15 megapascals or 15 million pascals, which is equivalent to a uniformly distributed force of 20 tons. Last, you have to map this pressure on the surface by selecting the face in the 3D window and clicking the Add Selection from Viewer button. Clicking on the constraint item in the project tree, we can define how the mount is fixed to the wall. Since the mount is completely fixed, we define all components with the value of 0 meters. Here again you have to map the boundary condition to the right surfaces. Select the inner surfaces of the 4 boreholes and click the Add Selection from Viewer button. The next item in the project tree is numerics, which contains all of the settings you can apply to the simulation regarding the mathematical methods which are used. We will not touch this item. Instead, we'll use the standard settings, which are fine for this case. Now all simulation parameters have been defined. Last but not least, we have to specify how the simulation should be computed. Again, the standard settings are fine, but you can accelerate the simulation by using more cores. We are ready to start the simulation. Create a new simulation run and press the Start button to launch the simulation. The simulation will start running soon. You will get a notification by email when your run is finished. Alternatively, you can also take a look at the progress bar. Thank you very much for watching this video. In the next video, we will interpret the results of the simulation together. Bye!